Seaborn is a Python data visualization library, which is like usually based on the matplotlib. Okay, it provides you a high-level interface for like drawing attractive things or giving more information on the statistical data. If I talk about that, okay. So it is an open source BSD licensed Python library, okay, which also works as an API, okay. So to learn this, you should have a basic prerequisites of like for the NumPy, the pandas, and all that things. Okay, that is a basic one. So if I summarize things what I have told till now, so Seaborn actually tries to make things easy and the hard things possible to plot on. Okay, so it tries to make a well-defined set of hard things easy to do. Okay, so with basically with the default parameters of matplotlib and the working of the data frames, it works with that. Okay. Okay. So the first thing is like how we can set up the Seaborn there, right? So for that, it's very easy. Again, like till now, whatever we have done, that is import Seaborn as SNS. And it depends what you want, SN or S or anything you want. Okay, so it depends on NumPy, it depends on SciPy, it depends on SymPy, it depends on pandas, matplotlib, Python, everything. Okay, so these are the dependencies of this Seaborn. Okay, fine. So first thing is to import the libraries. Now when you are working with Seaborn, you will be requiring the matplotlib, the pandas there, okay, the NumPy there. So the first thing you should do every time is to import the libraries needed. Okay, like what you can do is you can import pandas. Okay, why? For managing the data sets. So for managing the data sets, you will be taking on the pandas as PD. Okay. Similarly, for additional customization, we'll be importing matplotlib. Okay. So these two are the important features. Okay. You can also import from the matplotlib import pipplot as POT. And the Seaborn you import for styling and plotting the graphs. Okay, so for styling and plotting, we use Seaborn. Understood? That's right. Okay, so these are the basic. You should always import like things. Okay, done. Now, for loading any kind of data set, okay, because in the Seaborn you will be working with the data sets. Now you have read about the data structures and all those things, and you have right good acquired with the things of data. So when we work on data, that is called as like we are working with the data sets. Okay, so we have to import the required data sets whenever we work with that. Okay, so Seaborn comes with a few important data sets in the library. So when Seaborn is installed, the data sets download automatically. Okay, you can use any of those data sets while you're learning. Okay, so just you say import data sets. So that is like this data set, right? That is load underscore of data set. So this is a function what we use basically for the data sets. Understood? And you can get all the dataset names what are there. Okay, you can just whenever you want to load any data set, that is not importing a data set, okay, that is exactly loading a data set. You can say import data sets from Seaborn. If you want to import data sets from Seaborn, you can use this load dataset option, right? Okay, it's cool. Now, in Seaborn, right, if you want to import data from the pandas data frame, right, then you'll have to just write it as def and then head and all those things, right? So how many data frames, when I'm saying that you have got some of the free data frames to work on, then how many actual data frames you have got, right? So we'll see. So how many free data sets you have got to use on. So that is only if you just print that sns dot get all the dataset names. So you'll get a list of there, that is the ANSCOM, attention, brain networks, car crashes, timers, dots, exercise, flights, Fermi, gamma, and a lot of things are there, right? IVs, MG, penguins, planets, tips, a lot of things, right? So these are the data sets what you have got to work on, like, okay. So you can just bring any of the data set. You can bring any of one of the data set and you can just work with that. Okay. So let's just say that if I want to load any data set as a data frame or like in the pandas, right? So what I'll do. So let's say this df is equals to sns dot load dataset on, let's say we are loading the steps. So this is having a total bill, tip, the genders, smoker, date, time, and size, something. Okay, all right. So you will get some information regarding your data, right? Whenever you load something. So visualizing data is like one of the steps which makes things very clear in the field of data science. Okay, that is important actually to visualize the things in this data science field. Okay, so we'll be talking about things one by one. Understood? Okay. So see, the first thing is like we know about the plotting section, whatever we have built till now. We know all about the plotting things, how we can work with the plotting. So there are a lot of figure styles. Okay, there are a lot of figure styles. Figure styles are an interface for manipulating the styles of your graph, how you want to see it. Okay, those are the styles of how you want to see your graph actually. Okay, so that is figure styles you say. Okay, and that is are of basically five kind: dark grid, dark white, and text. Okay, that is the figure style you say. So let me write it there because many times I use these things and students have doubts. What are these things actually? So as I say, you have got some five, you can say, styles. Right? You use this as set underscore style. This is the like syntax what you do. Set style and then you give your styles to be there, right? You just like it as sns dot set style and under the parenthesis you write the style name. That's it. Okay, this is your uh, particular method of writing the Seaborn style. So how many styles you are having? What I say, how many styles you have? You have five kind, right? You have dark grid, you have white grid. I'll show you when I'll plot any data, I'll show you how it works. There is dark, there is white, there is fixed. Okay? Understood? This is how it works actually. Alright, a very easy one, you can say. Very easy to just plot the things, right? These are the, you can say, styles of, you can say this only the styles. That will be nice, right? So these are the styles to work here. Okay? What happened? Okay, you guys are here. I thought you loved the meeting. Alright, that was Python. Okay, fine. I thought you guys left it. Where was I? Here. So get style, and that's nice. Okay. So these are the style names. Now plotting, I said like, see again guys. Plotting you can do with any of the kind. Let's say you are importing numpy. And let's say x. Okay, this is x. Y to be the sign of x. Let's say if I'm plotting, if I want to plot this x and y, I'm plotting this x and y. And if I'm saying, if these are my data, and if I'm saying that I want to get the style, so that is SNS dot get underscore of style basically. And let's say if I'm writing white grid, and I'm using show. Oh, sorry, that is set style. So particularly you are getting some white grids over there that you can't see actually, right? So let's do it as black or dark grid. White is, now you can see it like this. Okay, griddings like you can see it. So how many kinds we are having style? We have text. So text is like you'll be getting some text, like you will be getting some labelings over there. If you don't use text, what happens? Like if you only use it like dark or something like white or like that. So if you only use dark, you can see like just the things you are getting, right? You are getting a graph right here. If you use white, so like you are getting completely white things and like that. Okay. So if you use text, what are you getting that? This is like, where it is. Okay. So there are some white, dark, white, gray, dark gray, and text. So that will be small t. So you can get your data anytime when you plot these things. Let's say this to be Z, this to be S. Plot between Z and S, set the size as text. You can get it, like sometimes it not comes then, but still You can get the things, right? Similarly, you have these are the access styles, like sorry, these are the you can say set styles, like what you actually get for the parameters. You can pass this dictionary of parameters to the set style, right? So similarly, you have access style. How access style works, you'll see. Why it is not working? White. Okay, let it be there. So, okay, before that, what I said that you are having some access style to override the elements. Okay, so like that is called as Seaborn access style. Okay, so you can get it as SNS dot the access underscore style, and then you can write on your style over there what style you want, the style name again, right, what style you want actually. Okay, so that you can do. So how many are there actually, how many access styles are there? So for that, we'll just print. Okay, we have imported Seaborn, so we don't require this step. So we'll say that we need to plot the SNS, and we need to get all the access styles we are having. So that is AXES access underscore of style. That's it. So, oh, it is not coming. So you have got all these styles, like the face color gives white and such like that, right? If you don't like write this in the print statement, you'll get an individual one that will that will be nice to see, right? Excess face color white, excess edge color 0.8, grid true, and a lot of things are there actually. So how to use these things? How to use this excess whatever you are saying, tick color and all those things, right? How to use those things actually. So let's say you are plotting this graph again, okay? And here I'm just passing a dictionary as like these are in the dictionary, right? So let's take any of the values. Let's take it access dot access below. Okay. So this is access dot access below. And let this to be false. So what you are getting? The difference between this and this background difference. Hmm? What if we write true? Okay. So there is some excess different you can see, like in the graph. If you see it very carefully, you can see some of the difference there. So that is like a lot of difference. You can't see a lot of difference there. Just a styling option is these are the just a styling options like patch and like the line solid direction of this, the face color, label color, the axis below to be true and all those. Like you can get a help from again you can get a help from all those things, right? If you just want a help, you just write help and then Seaborn for a particular thing, right? So there are a lot of color palettes. There are a lot of we'll using the color palettes are there. Okay. So okay, see, color palettes are something like which is again used for just for styling. You can say, okay, that is again used for styling purpose. So once again, okay. So as I said, there are a lot of color palettes in the Seaborn you can see on. Okay, so we'll see one by one what are actually color palettes, how to get these things right. So color plays a very important role in any of the graph whatever you plot, right? So Seaborn provides a function called as your color palette. Okay, that is LET double TE. Okay, this is the function of Seaborn, that is SNS dot color palette. So you what when you run this, what you get some values over there, right? These are nothing but the color values you are getting. Understood? These are the values you are getting from the color, right? So see, the usage is like you give the palette value, you give the let me write the syntax, then you come to understand. So let's say this is SNS dot, you say color underscore palette, and then you define previously, or you can say by default, this is like none, and the n colors. I'll be discussing what are these. So like this, okay. So if you run just this, you can see the whole thing as like this, right? Because everything is none there, so that's no use of writing any parameter without this and this, right? Okay. So what are these parameter? This none, n colors, and the etc. Okay. See, the n colors state the number of colors in the palette you want. Okay, so if none, the default will depend how the palette is specified, and by default the n colors are 6. Okay, so you get the 6 times, right? But if you define, then it's okay. But if you don't define, you get by default 6. Okay. Desat is the proportion of the desaturation color, right? You want the each color you want to desaturate. That is the proportion of the colors. Okay, we'll see. Don't worry. And return, there are some return things, right? Return refers to the list of RGB tuples, basically. Okay, there is one module called as one function called as return. Now, as I say, this basically refers to return uh, a list of RGB tuples. All right. So see how many basically RGB you can say tuples are there. How many kinds are there? If you focus on that, so that is like deep, that is muted, bright, pastel, dark, colorblind. Okay, these are the things, right? So we can use these things for plotting. Okay, we can use, and we have another function. We have one more function there that is like called as SNS dot pal plate, or you can say pal plot. This is important one. Why? Because it deals with all the color palettes. Okay, it deals with the color palettes. This function deals with the color palettes when you are working with your plotting these things. Okay, so this plots the color palette as an horizontal array, and you will get to see when I plot these things. You'll get to see that in a good way. Let's say let's say my current palette is just color palette I have written. Okay, that is basic. And I'm saying this a pal plot of this current palette. Cool. Okay. Of this current palette. And let's just show it. So you will see all the colors basically. So we haven't passed any parameters like by default. So by default we see 6 colors, right? So if you pass on anything like the number of colors you want, so like the n colors, remember this n colors. Now if you say you want some 12, so we're getting something like that. Okay, so this is the important of palette. Like you will get a particularly these things, right? So there are a lot of palette colors. There are a lot of things in the palette. How many palette colors are there? As I said, there are a lot of things, right? So let's say because these will be using in the graphs. This will be using their things, right? So now we'll be seeing some sequential color palettes. Okay. Now these are a plots. These are used to plot down the suitable expressions of data ranging from lower to higher values. Okay, that is like when you want to find the median or something like that. The maximum minimum value. So you have the same things, not to change any much more there. So like the things as your in colors, and let's just take it to be 6 now. Okay, okay. This is like I'm taking 6, but in the pal plot, the whatever you are plotting there, you just say it's in the greens. Okay, that is just a kind, different kind of that. Okay, when you plot this, what is the color palette called is not object. Okay, so fine. We work with this. Okay, that's nice. So you can see some colors over there, right? And depends on the kind what you want. So you write 12 and something like that, not working, right? If you even write 20 and all those things over there, it will not work. Why? Because there is some fixed limit actually in the kind of the color palettes what you get. Okay, so there is some fixed limit of different types. So how many are there? If you write as a blues, so what is it? These are not a valid palette name. So how many palette name are there actually? These are the palette name. Okay, these are the palette name. What you got? Okay, so you can use oranges. You can use, so it will be capital B, and then you can get it there. Okay. Similarly, there is oranges like that. Okay. So there are a lot of colors and a lot of palette. So how many palettes are there? If I just write a wrong one, so you'll get to see all the palette names. So these are the palette names. Possible are these things. Copy. Let's take any of. Let's take it to be. Any of the, let's say bone. If we take it bone, what comes? So this is bone, right? This is bone of reverse bone. So R stands for basically reversing the things. So how many possible color palettes are there? These much. Okay. So if you run, you'll see ascent is not defined and a lot of things are not defined, right? If any of the things are not defined, well, you can pass str to individual all of them. So you can write as this and this And like this you can write, but I'm not taking now. I'm just taking it as a value itself. Okay, that is a type what you can write on. Okay, these are the basic, all the things what you can write on. Like spectral is there, magma is there. That magma is nice one. If you go with that, that is looking nice actually. There are purples and a lot. You can explore these things on your own, right? So I like oranges there. That is looks actually nice. So this is like there. Okay. So like this, you can plot your graphs, you can set your types, and a lot of things you can do with that. Okay. Now we'll see the plottings actually. Okay. Now we'll go to see the plottings. What are the courses which are in the end of your courses? So the first is the histogram. Okay. You guys, yeah. Where were I? So like first is your histogram. Okay. A histogram basically represents the data distribution by forming bins along the range of the data, and then uh, you can say like it draws bars to show the number of observations that fall in each form. So if I write a definition, so I'll say histogram represents the data distribution by forming the range of data and then drawing bars to show the number of observations that fall in each bin. Okay, so that's the usage of like this is histogram, not Instagram. I need to correct it. Range of data, number of things, and bin. Okay, fine. So this is an advantage of using things, right? Right. Okay, so definition, these are like kind of things. So how to plot exactly the things, like if you want to plot on a histogram and you want to get it like there, okay. So how to plot those things? So let's say, so even I can just write on, I can speak and then the code will be written on there, right? So that's like import pandas as PD. Not like that. Import pandas as PD. Still, it's not working. All right. So that is nice if I just write on these things. Import pandas as PD. Now, see, for the histogram, the first basic things. It's still working. Yeah. So what I said is, for the very first things, what you require when you want to plot any histogram. So in pandas, you want only three kind. That is pandas. Oh, sorry. In Seaborn, you need three of the libraries: Seaborn, pandas, and matplotlib to plot any histogram, right? So let's say that you are taking a data, and since we have imported it previously, so we are not going that with that. So data set of iris. Okay, it is data set, and let's say in the histogram you come up with the first plotting that is called as dist plot. Okay, so it's actually distribution plotting. So you want to dist plot now. Okay, okay. Let's first see what your data is having. Otherwise, you will be like. So let's just see the head of this. So you are getting some sepal lengths. This is actually a data set of iris, which is flower. Okay, having some species, Etosa, versicolor, and virginica over there. Okay, you have some petal length, petal width, sepal width, and sepal length over there. Okay, different kind of things are there. So let's just quickly get an information of that. Okay, so like this, and how many species are there itself? So we'll get to see. So Virginica 50, Setosa 50, and versicolor 50, right? So you got to see all the things, right? How many total data you're having? That is 150 rows and 5 columns. Okay, among of that 50 50 50 are these all. Okay, so that's nice. So we want to just print you can say a desk plot. Okay, you can say this as basically a histogram where we use things called as distribution plottings. Okay, we use distribution plot here, right? So let's say SNS dot desk plot, and let's say to plot the petal length. Okay, so we are plotting a petal length, and let's give this KDE to be false. Now what is KDE? I'll let you know. So you'll get a graph over there, right? You will get a graph clear. So KDE is KDE flag. Basically, KDE is a flag. Okay, and it is set to false here. What I have written. Okay. So as a result, the representation of the kernel estimation plot will be removed, and a histogram will be plotted. What if you write a true? So what you can see is just plotting as well as a disk plot. Understood? So if you write a false, you will only see the histogram, right? So the kernel estimation plot will not be removed if you write true. That is the like importance you can say. Okay. Okay, fine. So as I said, there are a lot of things to discover with the KDE. So KDE is particularly called as kernel density estimates. Okay, understood. Kernel density estimates. Okay, let's explore this. These three terms are very important. This KDE, EDA. Whenever you apply for any, like when you apply for a data science job or like for the machine learning engineer job like that. So whenever you submit your resume or like that in any companies, they'll mail you something, right? They will first have a test session with you online. Okay, so mostly I have seen many students working with that, right? So how they give, like they give you paper, like a PDF you can say on. In the PDF, it will be written that this is a data. You can get data from here. Make a EDA report of this data and make a model of this to count such parameter. They will give you that. That's it. You have to solve that, and then like you can work with that, right? So there actually you have to go with the exploratory data analysis, the EDA part, and then you make some models over there to work with that. Okay, nice. So this KDE is a way. Okay, again I have to speak out. So kernel density, it's not started. Kernel density estimation is a way to estimate the probability density function of a continuous random variable. It is used for non-parametric analysis, like setting the hist flag to false in the disk plot will yield the kernel density estimation plot. Okay, so there is something written very bad, blood and all those things. Random variable is fine. It is used for non-parametric things. That should be okay. Cancel. So it is used from here. I'll remove these things. Okay. So this is fine. That kernel one thing has stepped out. So kernel density estimation is a way to estimate the not prob. It is probability density estimation. Okay. Or not, this is not estimation, this is function actually, as a way to estimate the probability density function of a, okay, it has been repeated. Estimate the probability. Okay, fine. So setting the hist, right, when you plot a histogram, setting the hist flag to false in the disk plot will yield the like kernel density estimation plot. Okay, Now, how these things actually works. So you have seen like how you can plot a histogram and all those things, right? So see guys, you can directly plot it as if you want a histogram to be plotted out. So you can plot hist, okay, and you will get a histogram of that if you plot the df of hist of that. So petal length histogram, sepal length histogram, and sepal width histogram. And if you want to plot a particular one, you can write histogram, okay, and then you can pass on like what do you want actually. So do you want the petal length? Okay, so ax is not defined. That is, you will be getting an histogram, exactly the same thing there, right? We'll discuss what are these things, okay? Don't worry for that. We'll go in detail with all those things. So let's just take it as a df, okay, and let's just take it your petal length, okay. This is your petal length, okay. This is your this, and you want to plot, what you want to plot is a histogram. That's it, a simple line step, or you can say a simple line thing to plot your data. Understood, right? I'm giving you possible ways on how you can make on your data. So if you use the desk plot, okay, there is one PDF I think in my desktop. It would be there. So where it is actually. So there will get a lot of things what you can do with the Seaborn. Uh, it is the business files. Hmm. Hmm. Not here. I think it might have. There it is. Okay. Fine. Let's just bring it there. Data visualization. No, this is not your thing. This is data science. And uh, let's take for the Python there. You might get it there. Python with data science. Yeah. So here there will be a graph of Seaborn. I think there it would be scikit-learn, keras. Mm, text files. No. Yeah. Fine. So there you can see like how you can plot your data, how you can get to it. Okay, so we'll see one by one plottings to all of the things, right? Why it is hanging on? Okay, so like the set styles, the C1 set styles. Okay, so there is one figure SSX, that is fx, and like subplots, and also subplots you have read in the matplotlib how you can make subplots, right? So there is something white gray text major and all these things we have studied. So yes. So you. Mm-hmm. Say yes. Any messages there? No. My system is taking some. Actually, It's hanging on. What's the issue? It is taking on. Yeah. All right. Rejoin. Shit, rejoin. Restart. Okay, fine. Yeah, Harita, we were asking something. Actually, the net was making some issues. Am I audible now? Okay, fine. So I was here that the styles we have seen, right? How to set those X styles and all those things, right? Fine. So now we were in the test plot, right? We were in one kind of test plot that is a kind of histogram actually. Okay. So distribution plot. This is like distribution plot, and like it plots some unvariate distribution. Okay. It plots actually the unvariate distributions. So let's just say that you are plotting a disk plot, or you can say this as it to be distribution plot, right? So this is a distribution plot, how it works. So you have seen, right, how this distribution plot actually works on, right? This one, SNS dot dist plot, and you can just plot it there. So SNS dot dist plot, and then just pass on what you want to plot it. Only if you pass like this, you'll get a distribution plot, right? But if you write your KDE to be false, we'll study now what is KDE. So you'll only get this one. Okay. What if you write true, and also the color? So you'll get it like this. Okay. Understood. So dependencies are there a lot of. Okay. So we'll try to understand this KDE, that is kernel density one. Okay. So what I was saying that in this KE, let's just take it below. Okay, so this KDE works with some parameters. What you have seen till now. Okay, so let's say that we are making a plotting, hmm, and that, when I say the proper histogram to be false, so you will only see a KDE. Okay, only a KDE, right? So you, what is disk plot, right? Why we use disk plot? So it is used to visualize the parametric distribution of a data set. Okay, understood. So just like you have printed out, so you have printed this plotting, you have got some things over there, right? So you can fit some parametric distribution. How you, if you want to fix some values over there, if you want to fix something there, so you can, if you don't write it like this, right? If you write that is color you want, it's P, invalid color. So I'll get it like, okay, write down colors, I'll get the value. Or let us say you want to write true, so we'll get a data frame like this. Understood. I think you might be clear with that. All those things. So let it be false. Like this will get. Okay. So this is the use of disk plot. So this works on two kind of data. Like see, you will be doing some machine learning concepts also in the end. That is tomorrow, sorry, day after tomorrow. So this data is actually of two kinds: unvariate and bivariate. Okay. Bivariate is where you have more than one data, and unvariate or univariate is like where you have one particular data. Okay, fine. So bivariate distribution is used to determine the relationship between two of the variables. Okay, for there, the best way to analyze a bivariate distribution is by using the joint plot. Okay, so joint plot creates a multi-panel figure that projects the bivariate relationship between two variables and also the unvariate distribution of each variable on the separate axis. Okay. So with that joint plot, we have two kind: scatter plot and Higgsbind plot, and all those things, right? The KDE we will see there. What are the KDEs and how these things works? Okay. So now we'll focus on the scatter plottings. So there we are going to see one of the things, that is joint plot now. Okay. So we'll try to understand this joint one. So color palettes you have seen, right? Color palettes, context functions. This is not of much use for you. Okay. But I'll make you see that too. Okay. Fine. So now we'll go to understand this join one, that is how this pair plot and all those things. Okay, these are actually, so you can see joint plot are used for a bivariate plotting with margins of unvariate plots. Okay, so this plot bivariate distribution. Okay, so let's just plot it. Okay, so let the data be same. So we are using joint plot. Okay, this is int tbc, and let's say your data is, now you want petal lengths to be plotted out, and with the same you want the separation with the petal width. Okay, we'll see how we can do a lot of things. And let's say that is only df, the data is there, and you plot this. So you'll get a plotting with some scatter plottings actually. Okay. So you got to see some scatter plots. So what are scatter plots? It is the most convenient way to visualize the distribution of each observation in two-dimensional data, right? You can write your colors. Okay. So you have seen just a joint plot. Actually, what does, if you have done only the scatter plotting? Let's say if you see only the scatter plot, you will see the data just only this, right? But now what you have said is you want the joint plot. We'll go with the scatter plot also. Don't worry. So joint plot will actually create a multi-panel figure for the object. Okay, with the histogram as well as with the scatter plottings. So it works like that. Okay. So you can see the relationship between the petal length and this petal width. Okay, in this iris data set. Okay, so this plot says that the positive correlation exists between the variables. If we just go, and this is a kind of study. This is, if you see, if you memorize, then you can see this is a category of Setosa. Okay, so similarly we have Hexbin plot. Okay, so we will be not using this all Hexbin and like this things a lot. So hexagonal binding is used in bivariate data analysis when the data is sparse in density and when the data is very scattered and difficult. What it is writing? Let me stop there. Man City, what is taking there? Mike is get wrong there. What is this? Okay, I'll have to write on my own. So hexagonal binding is used in bivariate data analysis. That's it. You just go for that. Okay, fine. So an additional parameter of kind and hex will be there in this uh, hexagonal plotting. Okay. So still we'll be just using this joint plot. Okay, but I'll be using just a different thing. Only one extra, you can say, parameter will be increased on. So we'll be going with the same petal length versus this petal width. We'll be again giving the colors to be, okay, don't give the colors. Let's say, okay, give it. This is the parameter only which is increased. That is the kind you want is hexagonal. So you're getting some data, right? And hexagonal plotting over there. So this is like the different type of plottings you are having. Okay. So KDE is a non-parametric, you can say, distribution graph. Okay. So that is, KDE works with a non-parametric distribution. Understood? So if you just plot on the data, if you again see the KDE, okay, fine. Let's plot it as KDE and let's give the color to be pink. And we'll see in KDE now. Yeah. So this is most of the time you can see a graph like this too. The petal width versus the sepal width, and this is actually graph. So you don't need to actually study on these. You will be asked to plot a graph on the basis of the density estimations, right? So this is a method you should remember how you can plot the graphs actually. Okay, so this Seaborn is all about like graphings and all those. Okay. Next we come to see visualizing pairwise, the pairwise relationship. Okay, so that is like the joint plot is done, right? We'll see now pair plot. Okay, so this plot pairwise bivariate distribution. Okay, so we'll see the pair plot actually here. Okay, so see, so pair plot is something which shows a relationship with a combination of variable with all of it rows and columns. Okay, as a data frame you can say all. Okay, so that is exactly called as pair plot. There you have three, four kinds. Basically, parameters are there. So if we just go with the parameters, so that would be like you are going with the pair plot. And you have a parameter data, you have hue, you have palette, right? You have kind, you have diagonal kind, and like that you have the parameters there, right? So data is nothing but the data frame what you want to plot. Hue is nothing but the variable in the data to map the plot as expects to different colors, like you can say label. Okay, palette is something the set of colors for mapping the label or the hue semantic. Okay, the kind is the kind of plot for the non-identity relationships, like the regression or the scatter plot, or what kind of plotting you want. Okay, and the kind is nothing but the kind of plot of diagonal subplots. For the diagonal subplots, what kind of plotting you have, what kind of plot you want, right? Whether a histogram or a KDE. Okay, so that is, you will see if I just plot on the things here, and if I just make it there to see, you'll see how good it looks, like formatting you can say. Okay, I will format some things and you will see that. Okay. So let's just say that you are having your data, right, the iris data, and only let's say you want to pair plot this iris. You want to pair plot this TF, that's it. So you see one by one the difference. I'll let you see there. Okay, so let's come here, and before going to that, let's see some of the settings. That is the uh, no, not here. Okay, you remember, I think there's all this set plot and all those. So you can see a graph actually with this, a basic graph, right? These are the sepal length versus the sepal length. So wherever the columns and the rows are itself compared, you will get a histogram over there. That is a diagonal graph you can see. So it is compared sepal width versus the sepal length graph, and all these x's you are getting the plottings over there, right? You can modify it one by one. So let's start at modifying. Okay, so let's say now I want to set my style to text. Okay, I want to set this as text. Okay, so let's just take it df equals to sns dot load dataset, and let's say this is iris. Okay, cool. And let's say we want a pair plot, and now I'm giving an this is df. Okay, just an introduction I'll be giving you to describe. The hue semantic I want on the basis of the species. So I will be, because in this data, can you differentiate which species, where is the setosa, where is the versicolor, which one is the virginica? Can you separate? No, because all are of the same colors, right? We can't separate which of, we know, I know this setosa is always a separatable category. So this is setosa, this is setosa, this is setosa. I know, right? Because I have seen many a times. But how can anyone just come to know like by seeing this data? No, not exactly they can. Okay, so we'll have to label something, right? We'll be labeling on the basis of the species. So, and let's say this diagonal kind, and let's say I want KDE, because we can see by default it's an histogram. Okay, so I want a KDE. Then the kind of plotting you want, you declare that, whether you want a scatter plot, whether you want a regression plot, whatever you want. So let's say I want a scatter plot. Okay, then the palette you want to use. So let's say I want to use the palette as okay, and that's cool. Let's plot it. So if you remember, your all the palette names are here, right? You can see most of the palette names from here itself, right? You can even find it from there, and also you have a lot of things here if you remember the things. Okay, so you will see a graph, and yeah, that's exactly the things what you can see. So now you can easily differentiate the things, that this is a setosa category, this is a versicolor category, this is a virginica category, and you can easily and you're getting a KDE graph there, right? So that is what you will be asked on to get it printed on. Okay, you can do accordingly with those things, right? Okay. Now we'll go to see what are scatter plots, what are kind of things there. So in the categorical plottings, we have particularly the scatter plot, the bar chart, the count plot, and all those things. Okay. So one by one, we'll go to all of them. Okay. So let's just go to a quick scatter plot data. So let's say these are height I'm taking. Sorry, let's take to be, this is weight. Eight, 65, 71, 76, and 73. That's nice. So similarly, we'll take some heights over there. 120, 136, 148, 175. Let's say 137, 154, 172, 187, and 1 2 3 4 5 6 7 1 2 3 4 5. Okay, 3 4 5 6 7 8. What is this? 5 5 10 1 2 3 4 7 8. Okay, fine. So the one there 162, 169. Fine. So there is some So this is height and weight, right? And you now we are going to see the scatter plotting. So if we just plot on things as SNS dot scatter plot, and let's say to plot the height and the weight. The height and the weight. Now there you write as x to be height and y to be weight, and just plot it. So you will see a graph there, right? And if you want a style over there, you can also put a style. Hmm. So you can just see the styling if you want, also the color if you want. Right, so yellow is not looking good. Pass on these things, or like red or blue, whatever you want. Right, this looks good. Okay, so like you can plot on the data accordingly to your. Okay, so there are various kind of plottings. So let's go to the scatter plot. Okay, so here if we see, like the scatter plot is particularly of two kinds. Like one is strip plot, another is swarm plot. Okay, so we'll go to that. So strip plot, strip. What are strip plots basically? Okay, so if we just see some definitions of this, so strip plot is used when one of the variable is categorical and it represent in the sorted order of one of the x's. So let's say it is used when one of the variable under study is categorical. Okay, so how to use that? Okay, how to use that? So let's say we want to plot a strip plot. Okay. So write this, that x as species. Okay, so let's just plot this on the basis of the species, and we want to y to be the petal length, and let's just say this data to be df. So species versus the petal length versus okay, fine, plot it. So you will get some strip plotting actually. Okay, so what have you seen that this versicolor, this setosa, and the virginica, you're getting actually a step plot, like and what range the values are ranging, and like in which or which you can say the difference between the petal length you can see on the basis of the things, right? There is one more parameter, that is jitter. Jitter. So what jitter does? If I write as jitter to be true, so that is like jitter. Okay. So if it is false, what's the major initiative and the difference between this? So if I write jitter to be false, you will be getting a strip plot like this. Okay. So that will be not very good to see, right? This is absolutely nice to see that. Okay. Similarly, there is one kind called as swarm plot. Understood? So swarm plot is another option which can be used as an alternate to in place of jitter if you use swarm plot. So this function positions each point of scatter plot on the categorical axis for avoiding the overlapping. Okay. So if we again go to this, so this you can see a swarm plot. Let's copy this. I'm not taking data again. Okay. So let's just take it. So this is a categorical scatter plot with non-overlapping points. This is you can see strip plot is being overlapping some of the points. If you just see on there, like it's overlapping. So this will not overlap actually. That's the major difference. This will avoid overlapping the data points. So swarm plot, data iris, and things are there. This is not iris, this is TF, and plot it. So if you see this graph here, you can see none of the points is like overlapping any of them. Okay. So this is one of the kind you say. Okay. Understood. I think you might have understood it. Similarly, if you see down, so we have bar plot. Okay. So we have bar plot. We similarly have the kind of box plots and all those, like with the box plot. So let's see the box plot. Okay, we'll go with the another ones, but let's see some box plotting. So what this box plot does? So it is a convenient way to visualize the distribution of the data with their quartiles, with the quadries. We actually deal with these quartiles in the R programming language. Okay, so this usually have vertical lines extending from the boxes, which are termed as whiskers. Okay, the line which will be like extending from the box will be termed as whiskers. These whiskers indicate variability outside the upper and the lower quartiles. Okay, so like if I print it, so it is used to distribute the data using, or let's say through quartiles. Okay, it's very easy to plot on that too. So let's just say you want to plot a box plot, and the same parameters we are taking, the species versus the petal length, and data to be DF. So you can see this extended lines are called as whiskers. Okay, so the dot on the plot indicates the outlier. Okay, that is an outlier basically. Okay, so these are the so any outliers in the data plotted are the individual points out there. Okay, So those are the exceptional individual points. Understood? So like that box plot just gives data actually. If you just see on, so if you see the difference like here, so the versicolor is having plotting from 3 to 5, right? From 2.9 you can say from 2.9 to like 5.2 or 3. Okay. Similarly, if you see your box plot, so what you are seeing, values are ranging from one particular value is in the 2, and the mostly values are ranging from 2.3 to like 5 point something, right? If you see on here like the data, the same things are just printed. Most of the categorical values are ranging from this area. If you see on the graph, so most of the things are in this area, and similarly, you are getting these things. Okay, like this is working on how. Similarly, you have there is some data of tightening data set actually. Orientations you can write like this is an orientation actually like uh, H stands for horizontal and V for the vertical. If you want orientations, you can write for that too. Let's say so like operand, string and integer are there. Okay. Okay, there, it's actually all the data to be in the string. So that works. Okay. So here you can see like the petal width, the sepal width, and all those things. You can even make your visualization enlarge as like using plt.figure, and there you write the fig size and tell it to be whatever you want, 10 cross 8 or whatever according to you. So 10 cross 8 is pretty very big. So let it be 8 cross 8. That would be nice. Still it big. So 5 cross 8. Okay. It's taking there. So 10 cross 5. So you can see the data, right? So it is like the petal width and all those things you are getting there, right? You can even find out the basis of hue semantic if you apply hue there. Not working. Cannot use hue without X and Y. Okay. So you can see your data actually. Okay. That's nice. Similarly, you have another one called as violin plot. If you see here, this violin plot. So a violin plot is something where you use this plotting actually for a combination of box plot and the kernel density, KDE basically, the kernel density estimates. Okay. So this is a combination of the box plot and the KDE. Okay. So listen, if we write this to be okay. So let's say if we just plot the data. And so let's give some parameters. So you can see some violin plottings there, right? That is actually with the KDE and all. Okay, so this is how this things works. Violin plot. Okay, you can give your you can say hue semantic to work with much better if you say hue to be species. So that will be also like distributed on the basis if you go with that, right? So like this you can get your things. You can even pass on the color. Okay, you can pass the color or the map, C map you want. So why it's not taking out? Okay. That would be blue. So you can plot your data accordingly. Like you see, you can give your colors and you can get it your things over there. Okay, so it's easy to plot on the things. It's very easy to just visualize the things and all. Okay, but there should be some parameters of working. Right, there should be some areas to go with that. Okay, so okay, so you have understood the violin plot, the box plot. Let's go above and let's just see this bar plot. Okay, the bar graphs. So what this bar graphs do, the short definition is, it shows point estimates and confidence intervals with scatter plot glyphs. There's nothing graphs, scatter plot graphs you will be getting on, right? So you get basically a count of everything on the basis of this bar plot, right? Well, let's say for writing the definition, you can write it as that it shows the relationship between a categorical and a continuous variable. Okay, so data is represented in the bars and the orientation can be changed on, right? So let's just say this is the bar plot we want, and the key parameters. Let's say you want to plot the species, or let's say you want to plot the petal length, you want to plot the petal width, and your labeling, that is the hue semantic, is species, and you are saying your data to be DF. You will see a bar there, but exactly a big bar like this, obviously, right? What you can see is a bar, but not a good one. So let's just load some different data and let's plot a bar graph there. So let's say let's load the titanium dataset. Let's just print their gender on the basis of their survival. And let's take hue semantic to be the class. So I'll be checking the number of people who survived on the basis of their sex and also on the basis of their class they were traveling on. So this is the data you'll be getting. Okay, this is the format you'll be getting in your So you can even pass on the C. So color palette, if you want, you can set again if you memorize the things from the starting. So color palette was, if you see here, the color palette. So you can just give on the color palette to any of the kind, right? If you write SNS dot the color palette oranges. Like this. Okay. So you can get out the data from here also. It depends what kind of things you are expecting. So let's wait. Yeah. So you can get your data, the first, second class, and the third class according to that, right? So what do we see? That this is the survival, this is the sex. So we can find that male on the first class, right? Male in the first class survived much as compared to the second and the third class. That's obvious, right? Females in the first class survived much as compared to the second class and the third class, right? So also we can see that the male were very less survived. The total number of males survived were very less as compared to the females. You can understand a lot of things with one particular plotting. Okay, that is important. Okay, so for getting such a generic plot of all those things, we use something called as count plot. Okay, so for getting something much good plotting with that, we use a kind of thing called as count plot. So this shows the count of the observations you are making. Okay. Let's say so. See again, if I just plot the data, if I just want to see that how many people were there according to this sex, okay, and if I just want this to be BF, and let's say palette, we want to use it oranges, okay. So we can see like that there were some 500 plus males and around 300 plus females. Let's take something different. So it'll be a green and blue data, yeah, like that. So there you have a lot of things. There's pink here. There's cool one. That's nice. Yeah, that is exactly nice. So you can see the number of male over there and the number of female over there, right? Similarly, you can also write with the same thing. Let's say you need to plot this data, and let's say you want to plot this on the basis of their class. So now you could see the data something as this, and let's just change the type. Green should be G capital, I think. Uh, where it is, where it is, where it is, where it is. Let's take to be spring, that is fine. Any palette use things works basically. Only the thing is it's to be working on. Let's take a reverse of this. Okay. So I can see it's not looking good actually. spectral. Ocean is there. Ocean will work nice. Okay, fine. That's it. So the number of males in the third class were much greater as compared to the number of females and males in the first and the second class, and also in the third class, right? So this is how you can see, particular if I say this is how you can see this plottings. Okay, 1 minute. Okay, so this is like how guys this count plot works. Similarly, you have point plots. Okay, this is point plots now. So point plots serve as a bar plot, but in different style actually. Okay, so in rather than a full bar, you get some points in place of some bars. Okay, so no definitions for this. So let's give a point plot, and let's say you want to plot this sex again on the basis of their classes or on the basis of their survival, and the data you are giving it's D and the palette you are using it's, let's say, this to be pasted, and let's take I'll be differentiating them on the basis of the classes, and let's see the graph, and this is the graph. Nice. So the third class people were like very less survived. If you see, the third class were very less survived. The first class male were survived less as compared to the female were survived very much. Okay, the female survived a lot as compared to the male. The second class females also survived very much as compared to the males in the second class, and the third class in the males survived very less as compared to the females too. Okay, so we can see the data there. Understood? So this is a point plot, you can say. Okay, so an estimation of things you get, a statistical estimation is said to be. So I hope everything is like clear to you guys now, like how you can plot different kind of things with something. Okay, fine. Any problems or understanding anything? What's the time? 1:44. Okay, we can see 2 or 3 plottings over there. Okay, so now we'll see some multi-panel categorical plotting that is coming under the category of factor plot. Okay, so till now we have seen all these things, right? The categorical plotting has been done, all the plottings we have seen. Now we'll go with this factor plot. Okay, the facet grid factor plot, LM plot, and all those. So factor plot draws a categorical plot on the facet grid. Okay, it uses a kind parameter like we used in the previous graphs, and there you can give your things. Okay, like with the box plot, pylon plot, bar plot, strip plot. You can use any of the parameter to plot it there, right? So let's there is one data set for an exercise. Okay, so let's load the data from there. What is in the exercise? If you see, so exercise I'm loading, and will then factor plot this. The x would be the time, The y would be the pulse, and the hue semantic would be the kind, and the palette HTTP error, file not found. Warning message. All right, fine. So see, this is like nice. You are getting a data. If you just see on the head of this data, what you will see, you're having some. Okay, don't go with this unnamed. Uh, so like you are having ID, you are having diet, the pulse, the time, and the kind. Like for a low fat, the pulse rate is there, and the like diet time is there, 30 minute. The kind of thing is doing is rest. Okay. So like this, you are getting a graph actually. So you see on the basis of things, right? That is 1 minute. That's the kind of things what a person does most of the time. That is rest for 30 minutes, 15 minutes, 1 minute. Walking is like, if you see for the running is very much there, right? In the pulse. When we run on, what is our pulse rate, right? When we walk on, what is our pulse rate? When we rest, what is our pulse rate? That is like for the time durations. Okay. Fine. So you can, as I said, that you can give kind parameter and plot these things in various kinds. So that is like, so let's just take a kind. Okay, let's just take that. So here, if you give kind and you want a scatter plot, let's say. So yeah, comment. Scatter is not recognized. Okay. So we can use its subplottings like the strip plot. This is also not recognized. Let's remove the plot. Alright. So like the strip plotting you can see. Right? You can go with the swarm and the bar and the box, all of them. You can go with the box or the violin, what I was saying, right? Like this. So what should be the pulse rate while doing some things, right? You can go with the same like as for the violin, like that. Okay. Also with the bar plots. Understood, right? This is like how we go with the factor plot. Okay, so this draws a categorical plotting on the basis of the data, like the kind parameter you're using. On the basis of this, also facet grid. Okay, so what is exactly a facet grid? If we talk for the facet grid, what is a facet grid? Okay, let's move on to the facet grid. So facet grid forms a matrix of panels defined by the rows and the columns divided by the variables, right? It will be just a panel of some rows and columns, like in a histogram you can say on, but there you have to define what kind of things you want. Okay, so due to the panels, a single plot where it looks like a multiple plottings over there, right? So let's just plot the same thing, not taking there anything else. Okay, So let's just plot this. This the only change we'll be doing is we'll be doing some kind here, like hue semantic and all those are given. That's nice, but let's give it here. Yeah. So kind has been given there, right? Let's give a colon. Let's give it to diet. Okay, let it be a diet, and everything else is fine. Let's plot it. So we can see diet with no fat and diet with low fat. Okay, so that is the like factor plot. It will create some factors over there with that. Okay, understood. So that can create various factors according to this, right? So let's say with the Titanic dataset, if you want, so if you are taking for the Titanic dataset and you are taking a factor plot of that, so let's say you want to check how many survived, okay, how many survived, and you are saying your colon should be on the basis of the colon should be the deck, okay, right, and let's say your data would be the let's say it's the SNS dot load data set Titanic. The data set, and you can see a lot of like the deck on the basis of the deck, right? You can give on the basis of their sex. So this is a kind of thing you will be getting actually the plottings. Okay. So let's say to see the alive on the basis of the deck, and also let's wrap the column to the three in one row. There would be only three columns. Okay. So data has been given, and let's just go with the kind and this count. So like this you can see having a data. It is at deck A you are having some counts, deck B, deck C, D, E, F. So in some particular decks, these were the number of person who survived on like that. Okay, on the basis of their decks you can find out. So a life where something yes and no with that. Okay, fine. So that is how these things looks. Okay, facet grid is something different in itself. If you want to see the facet grid, we'll go with the facet grid. So see facet grid how it does. Let's take a data. So it creates a relationship between those things, right? So let's say you are saying like this. So the facet grid you will be getting is a black, right? So you'll have to pass on something like you want to map this data, right? Let's say this is G. So you want to map this data according to the histogram and with reference to the age. So you'll see a graph now that is this much people survived and this much like on this basis, right? If you do on the basis of the class, you'll get the data like this, right? And okay, so if you go with the basis of his, so it depends like how you can. Now, when we learn this all, when we'll learn this machine learning modules and all those things, there we'll see some kind of regression plottings, LM plottings like that. Okay, so we are about to end this Seaborn. All right. So facet grid actually takes data frame as an input, and it gives the name of the variables and the rows and the columns over there. If you don't understand with this one, let's give me another example for you. So let's say df, and let's say to be tips, and we want a facet grid hmm, of this df, and the columns or the columns we want is time. That's it. And just run it. So you're getting some blank things there, right? So we have just initialized the facet grid object, which does not draw anything there, right? This is nothing has been drawn here, right? So the main approach for visualizing grid or like drawing there is facet grid dot map. So you have to map something there, right? So with the map method, you can find it there, right? So let's say if I say g dot map, and we want to see a histogram of this tip, then you will get access argument was not found in the figure g dot map g dot yes, tip was not found. Okay. Sorry. So you can see the like the lunch time and the dinner time for like that. Okay. If you see your data, if you explore the data, then you can come to know, right? So the number of plots is more than one of the parameters. Like you can also give the palettes and all those things. Like you can give this. It's not working. Hmm. So I palette dot 16%. Scatter plotting will have some. Okay. Why is it not doing colors? I think I was giving in the wrong place. Yeah. So that's it. Okay. So this is like how you can give the facet kinds or grid. Okay. Similarly, there is one called as pair grids. Okay. So pair grids is nothing but the pair plotting what you have seen. So that if you want to see according to the grid, you can plot it with the grid, right? So the only thing is left out is the kind of plottings based on the models, like the regression plots and all those things, right? Kind of plottings you can say. So there is something a range plot and an LM plot. Okay, so we have seen all this. LM plot is left. We'll see now. Okay, regression plot also we'll see now. Distribution we have seen. Heat map is one of the most important thing, right? We'll see heat map also. What's the time? Charge. Okay. heat map will start tomorrow. Okay, so let's just go here. So if you see the LM plot, what is that? That is plot data and regression model fits across a facet grid. That does. Okay. So see, reg plot accepts the x and y variables in a variety of formats, including the NumPy arrays and the Panda series objects as a data frame and all. Okay. So let's just take it as LM plot and LM plot. Okay, this is plotted. So we are plotting the same thing. Okay. So let's take a data. From the steps. And let's take the total bill. And this y to be the tip. Yeah. It's not affecting that. Where the solve works actually. Okay. So what you can see is just a line over there, right? That is basically giving you a required parameter. Okay. So it is whatever the format you are getting is a long form. Okay, the long form things. Let's just take it to be with respect to reg plot, and let's see the difference. So the reg plot. So why it is not working? Okay. Okay, fine. It's not working. And then plot. Mhm. Species are not getting. On the basis of D6. Ah, that's nice. School. Kind of 6. So plottings. So what is the difference if you see? The only difference if you want to compare there is difference. There's only a bit of difference there, right? There is this regression plot accepts the x and y variables in a variety of formats, and the LM plot has a data which require parameter of the x and y variables to be specified in strings. Okay, that to be specified in the form of strings. That is for the LM plot, and this is for this reg plot, right? And so from tomorrow we'll go on studying this heat map. There is one matrix plot actually. Okay. So matrix plot, what matrix plot does, it gives you an correlation format. It gives you basically form of a box if you go with that. So let's just write matrix plot. So like if you just want to plot matrix plot, so matrix plot go with some lot of things like as a heat map and all those. So I'm just giving an just an information, like you can get it just like grasp. So let's say, or let's bring a correlation of this data frame. So like you will get a correlation. Okay. So this is all for today. We'll focus on this heat map from tomorrow. Okay. We'll come to an end with heat map. So all the things will be just like clear. Okay. Everything will be like clear, and then we'll start our modeling part, like the regression, and we'll complete your course. Okay. So let me stop this video.